In this video, we are looking at general argo definitions and Radian measures. We're going to start by looking at an argo in started position. What does this mean? An argo in started position is when the vertex is located at the origin. So this is the origin, this is the vertex, and one ray is on the positive side x-axis. The ray on the x-axis is called the initial side, and the other ray is called the terminal side. So here, this is the vertex, the origin. This is the initial side, which is on the positive x-axis. And then we have the terminal side of the argo. And here we are to draw an argo with a given measure in standard position. And all we need to know here, where do we start measuring the argo? Where is the initial side? It starts on the positive x-axis. So this is 240 degrees. So I'm going to start here and I'll go to quadrant 3. So that will be the terminal side. And this is the 240 degrees. Okay, now let's do negative 50. So negative 50 means I'll be going in the counterclockwise direction. So I just approximate. And that's going to be negative 50 degrees. This one is 405. That means to get to 405, I have to go one full cycle. So negative 360. So I get 45. So this is the same as going 45 degrees. So that is my 400, and that's the equivalent of 405 degrees. I mean, I could draw a full cycle showing how many times I have to do that, but that's the equivalent. Now let's look at another concept here. It's called quadrantal argo. If the terminal side of an argo lies on the axis and this is such as 0 degrees, 90, 180, 270, 360. This is called a quadrantal argo. So in this case, the argo is not going to be in the quadrant 1, 2, 3, or 4, just going to be on the x or y axis. And those are the quadrantal argos. We have 4, 1, 2, 3, 4, 5. 360 is the same as 0. So 4 quadrantal argos corresponding to the axis. Now, another concept we need to know here is called coterminal argo. And it says if two argos in standard position have the same terminal side, they are called coterminal argos. In the diagram on the left, we have 120. So let me go ahead and draw 120 degrees. So if I do 120 degrees, so this is 120 degrees, so about that point. And then I have, this should be negative 240 degrees. So 120 degrees. And I also have negative 240 degrees. That's if I go the other way, counterclockwise. So if I go, that's negative 240 degrees. And maybe let me use a different color here so that we can be able to distinguish. So that argo, which is negative, so that's negative 240 degrees. And this is 120 degrees. So those are coterminal argos. They take you to the same destination, or they have the same terminal side. Okay, let's look at some examples here to understand this fully. Determine the quadrant in which the terminal side of the argo lies 130. Which quadrant is this? So this is quadrant 2. What about negative 336? So here you have to go, you are almost at 360. So this is going to be in quadrant 1 because we are going counterclockwise. 285 is going to be in quadrant. So 270 is a quadrantal argo. quadrant 3, so this is going to be quadrant 4. Okay, find coterminal argos. So how do we find the coterminal argo? So we get it by adding or subtracting 360 degrees. So for 34, if I add 360 degrees, so I'm going to get 394 degrees. And if I subtract 360 degrees, I get negative 324 degrees. In the same way, negative 45, this is the same as negative, I can add 360, so this is going to be the same. If I add 360, what do I get? So I get 315 degrees positive. So 315 degrees. If I subtract 45, I get negative 405 degrees. Negative 120, so I'm going to add 360. So this is the same as 240 degrees. I subtract 360, negative 480 degrees. 300, I add 360, so I get 660 degrees. And then I subtract 360, I get negative 60 degrees. And you can see there are many possible argos. These are not the only possible, because I could add multiples of 2 pi, or multiples of 360. So there are many other possible argos. So in this video here, we are looking at radians, and we start by defining a radian. So argos can be measured in radians. To define a radian, consider a circle with a radius r centered at the origin. 1 radian, an argo of 1 radian, is an argo in central position whose terminal side intercepts an arc length of r. So this is a terminal side. You can see the arc length here is r. So this argo is 1 radian. And if you keep counting how many radians in a circle, you're going to see that we have 2 pi radians in a circle. 2 pi radians. And if you look at this formula, it's like 2 pi r, the formula for circumference. And let's equate this to 360 degrees. So that means 1 radian is going to be 360 degrees divided by 2 pi, which is equals to 180 over pi. So 1 radians is equals to that. So if 1 radian is equals to that, we can now be able to convert degrees to radians. When I'm given degrees and I want to get radians, all I need to do is to multiply whatever I have by pi divided by 180 degrees. So that you get rid of the degrees and leave me with the pi. So pi radians. Okay, to convert to radians from radians to degrees, I'm going to multiply by degrees divided by pi. And we're going to do some examples, convert to radians. So here I'm given 315 degrees. So I'm going to take 315 degrees. I'm going to multiply by pi over 180 degrees. And when you write the argos in radians, you just want to leave it as a simplified fraction. So here, let me put this in the calculator and see what kind of, how I can simplify this. Or I can simply divide by 45, each one of them, and I get 7 pi over 4 radians. The next one, I'm going to convert to degrees. So how do I do that? So I'm going to do negative pi, and I'm going to multiply by negative pi over 6, and I'm going to multiply by 180 divide by pi. And you can see the pi cancels out, so I'm left with negative 30 degrees. Then we go to the next one, convert to degrees. So I have 3 pi over 7. You multiply by 180 divide by pi. So what do we get here? This, remember the pi cancels out, and we get about 77.14 degrees. When it's degrees, we can leave it in decimal, but when you're using radians, just leave it as a simplified fraction. Here, we are going to find the coterminal argo in radians. And I'm going to show you an easy way to be able to do this. So remember, we find them by adding or subtracting multiples of 2 pi, 360. But because we have fractions here, let's make it easy. And here there is a limitation. The argo has to be between 0 and 2 pi. So here I have 11 over 4. So I make this a mixed fraction. So this is going to be 3 and 3 over 4 pi. Remember, my answer has to be between 0 and 2 pi. So what do I have to subtract here? I have to subtract multiples of 2 pi. So it's either 2 pi, 4 pi. So I can do 2 pi. So what do I get? 3 minus 2. So I get 1 and 3 over 4 pi. Is that correct? Is that within 0 and 360? Yes, which is the same as 7 over 4 pi. That's my answer right there. Now let's do the next one. 19 divided by 3, what do we get? So 6 times 3 is 18, and 1 over 3 pi. This is minus. I need to add multiples of 2. So 2 is not going to get me between 0 and 2. 4, no. So I'm going to add 6 pi. And what do I get? Negative pi over 3. Or negative 1 over 3 pi. Okay, we go to the next one. So this is going to be 23 divided by 4 is equals to 5. So is equals to 5 and 3 over 4 pi minus, I can only got multiples of 2, 4, 6. So which one will get me between 0 and pi? So this is going to be, I can subtract 2 pi, I can subtract 4 pi, and what do I get? I get, what is the balance? 1 and 3 over 4 pi. But the final answer you want, we don't want to leave it as a mixed fraction. So this is going to be 7 over 4 pi. Okay, remember, you could also subtract. Remember, there are many possible answers here as long as your answer is within that range. Okay, 31 over 6, what do we get? So we get 31 divided by 6, so we get 5 and 1 over 6 pi. So I subtract 4 pi And what do I get? 1 and 1 over 6 pi, so which is equal to 7 over 6 pi. And that's how to find the coterminal argos in radians.